So here we have 16. Apply the relationship giving the charge as a function of time and time constant for a capacitor in a charging RC circuit. You can read the information about the charging a capacitor from the original lesson, but don't stop here. You need to study everything. Be careful. Like maybe some in the objective they say charging, in the exam comes a discharging circuit, so make sure that you study everything and not just the Heikel. This is the equation, or the charge function with respect to time. When we charge a capacitor, the charge will start to accumulate on the plates of the capacitor. The negative charge will accumulate in the bottom plate, and you can see that the positive charge is accumulated on the upper plate. This rearrangement of charge will continue until the capacitor is fully charged. Once it's fully charged, the current will cease. There is no more movement for the charges. So I becomes 0, and the capacitor will be fully charged, and it will have the same voltage as the battery. If you want to find the amount of charge accumulated on the capacitor at any moment, we use this equation. Qt, which is the amount of charge on the capacitor as a function of time, is equal to Qmax, which is the maximum amount of charge a capacitor can hold. Of course, that depends on its capacitance. Remember that Qmax equals to C VMF. So the larger the capacitance, the more charge it can store. Okay. Also, don't forget it's multiplied by the voltage source connected with the capacitor. Alright, so Qmax multiplied by 1 e to the power minus t over tau, where tau is the time constant. Tau depends on the value for the resistance and the capacitance of the elements connected in the circuit. The higher they are, the more time it takes the capacitor to store charge. At t equals to 0, or once the switch is closed, the amount of charge on the capacitor is still 0. After a long time, the amount of charge on the capacitor will start to increase. After a long time, at t equals to infinity, the charge on the capacitor is the maximum charge, which is C, the capacitance in farads, multiplied by the voltage of the source. Alright, this is the time response of charge on a charging capacitor. Question says, an RC circuit consists of 12-volt battery. The charge on the capacitor as a function of time is given by Qt equals to 6 times 10 to the power of minus 4, 1 minus e to the power of t over 0.1. The question says, what is the capacitance of the capacitor in the circuit? Now remember, for a charging of a capacitor, is written this way. So Qt is equal to Qmax. Of course, this is a charging circuit because here we have 1 minus e to the power of t over tau. If it's just e to the power of t over tau, this is a discharging circuit. So Qt is equal to Qmax 1e minus t over tau. That means that this value here is Qmax. So Qmax is equal to 6 times 10 to the negative 4. And this value right here is tau. So 0.1. I know that Qmax is equal to C VMF. And I have VMF, so I can find the capacitance of the capacitor. So Qmax is equal to C multiplied by VMF. So 6 times 10 to the power of negative 4 equals C multiplied by 12. Divide both sides over 12. You'll see that C is equal to 0.5 times 10 to the negative 4, which is 5 times 10 to the negative 5 farads. Just move the decimal points one decimal or one place to the right, and when you're moving it to right, this one's getting higher, so this one must be getting smaller. So what's smaller than -4? It's -5. So the capacitance is 5 times 10 to the negative 5 farads.